In this video we're going to talk about naming derivatives of benzene, and it involves learning some new names. These compounds here in table 11.1 are some of the most common derivatives of benzene, and what you need to know in particular are these common names over here. Those systematic names in the middle are hardly ever used, even though they are the quote official names. It's these common names I need for you to know. If I ask you to name one of these, it's acceptable to give me that systematic name in the middle, but on the other hand, if I give you the written out name and I'm wanting you to give me a structure, I'm likely to give you one of these common names. So these you just have to know them when you see them. Need to add to this list one particular important compound of benzene. Kind of surprised they left this one off. I'll draw it over here to the side here with my limited penmanship. This is what we might call methylbenzene, but it really goes by the name toluene. So you can add that to your collection. We'll encounter a few other compounds, and we can kind of name them as we go, but having these in hand is a good starting point. Now there certainly are lots of substituents for which there is no special name. A bromine atom on benzene is just called bromobenzene. Tertiary butyl group, tertiary butylbenzene. NO2, we haven't seen that group a lot. That's called a nitro group, so an NO2 group on a benzene ring is therefore called nitrobenzene. Simple enough. Now when you have two substituents on a ring, there's two different ways we can handle this. We can number the carbons in the ring and refer to the locations of the substituents, similar to what we do with straight chain compounds. But there's also another way that's common in the world of benzene chemistry, and that has to do with what you see here, the little O, M, and P. This O here for orthoxylene, and xylene is just a common name for dimethylbenzene, but it's okay to just call this dimethylbenzene. We can say that these methyl groups are at a 1,2 position relative to each other, and it's certainly okay to call it 1,2 dimethylbenzene. But that O stands for the word ortho, and ortho is another way to refer to two substituents that are in a 1,2 arrangement. They're right next door to each other. Another name for the 1,3 situation that you see here, that little M here, that stands for the word meta, M-E-T-A. So we can call this metaxylene, or you can even say metadimethylbenzene. The P here stands for the word para, P-A-R-A. So this is a para isomer, which corresponds to a 1,4 isomer. So using the numbers or ortho-meta-para are equally correct, but again, when you see a little O or an M or a P, you need to know what that arrangement refers to. We can use this when there are precisely two substituents on a ring. If there's only one, we don't need these designations, and if there's more than two, then we would have to go with a numbering scheme. Here are a couple more examples of that in action. Ortho-dichlorobenzene, the 1,2 isomer. The two substituents don't have to be identical. Now notice there's a methyl group on this second ring, and so that's the basis of calling this toluene. And so the nitro is 2 carbons away from that methyl group, so we can say it's meta-nitrotoluene. But the numbering here puts the number 1 carbon at the methyl group. Since we are naming this as toluene, that does designate the number 1 carbon as being right here down at the bottom. And if we go counterclockwise, we can say the nitro's at the 3 position, because we do want to count in the direction that gives us the lowest numbers. This third one here, this also has a special name. This group at the top, that's called an acetyl group, but the official name from that table I just showed you, that's what makes it acetophenone. The fluorine is at a 4 position from that, so we can call it 4-fluoroacetophenone, or alternatively para-fluoroacetophenone. Either one of those is fine. Here's a sample problem from your textbook incorporating some of these special names. They give you the answer for this first one here. The anisole is what we call a methoxybenzene, so that OCH3 group makes that first one anisole, and the ethyl group is right next door, so we can call it orthoethyl anisole, or 2-ethyl anisole would work. So you can do these others and use those as examples to help you as well. I'll go ahead and see if I can draw in the answers to B and C here. Over here I'll do B, that metachlorostyrene. As long as the double bonds are alternating, it really doesn't matter which carbons have the double bonds. That's a single bond down here. And it really doesn't matter where I start putting my substituents. Styrene means that I have to have this carbon-carbon double bond as a substituent. And then metachloro means I can come counting in either direction to put the chlorine at a 3 position. It could also go over here if I wanted it to. That last one, paranitroaniline. Make sure we put in double bonds though, so it doesn't just look like it's a cyclohexane. I'm having trouble with my double bonds here. Let me retry that here. I'll point my ring in a slightly different direction here. So again, aniline, I have to know that what aniline refers to is this NH2. That's sometimes called an amino group. When it's on a benzene ring, it's called aniline. Para means that at the opposite side, I've got a nitro group, and that is NO2. So paranitroaniline.